This is just a quick video to respond to a very good question that came up in the comments today. The question was, is the address space of the ROMs mapped into the address space of the 6800 processor? And obviously the reason for the question is that if you recall, I said that the reset vector was at 3 FFE according to the decompiled code. Whereas if you look at the data sheet for the 6800 processor, the reset vector is actually at FFFE, not 3 FFE. So in other words, the reset vector would not hit any of the ROMs. So again, if you recall, this was the table, the ROM map, and you can see that the address range is not within the FFFE range of the reset vector. So in theory, none of these ROMs would be accessed during a reset. So the answer to the question, there is no real explicit mapping as such of the ROMs other than they sit within the address space of the 6800. The way that's achieved on this machine is very simplistic. So if we look at the way it's mapped out, it's a 16-bit address. This is the reset vector within our memory map for the ROMs, and this is the reset vector of the processor itself. Now if you write out these N2 numbers, you'll see that if you have an F, it's 4 ones in binary. If you have a 3, it's 0, 0, 1, 1. So the way that the reset works on this machine, and in fact the way that the ROMs are mapped, is these 4 bits determine which ROM is being accessed, and then the lower 10 bits, because it's a 1K ROM, determine what the address within the selected ROM is being addressed. Because we're ignoring the top 2 bits of the fully qualified address space, when we get the address FFFE, it will still access the top ROM. So if we look at the table again, if you were to convert this and we ignore these top 2 bits, then you'll see that what we're effectively doing is accessing it with these 4 bits. So we're accessing this ROM within these 4 bits as a 1111, and that selects ROM ID 307, and then the remaining 10 bits are used to select the address within the ROM. So if the remaining 10 bits, so those before 4 ones, and then on the 10-bit address we would get nine ones and a 0, and that will give us the address that we need to get to the reset vector. So in other words, if you ignore the top 2 bits, we've got 3 FFE, and that's how the reset vector from the processor manages to access a ROM that's sitting in this particular address space. The other unused bits are actually used to access the hardware PIAs, and of course the RAM is accessed lower down using a chip select mechanism. We'll look at that another time. But this is how the ROMs are accessed within the memory space of the 6800 processor. So there's no fancy addressing or remapping. It's just a simple bit mapped system. So I hope that explains that. If not, just drop a comment and I'll go into it in more detail, but I don't really want to spend too much time going over how the 6800 works and how it's implemented in this system. What we're looking at really is how to reverse engineer the firmware, but I'll be more than happy to answer any questions if you have any queries.